Okay, yeah. So looking at this question, let me read it one more time just for the clarity. Are freshman psych majors just as likely to change their major before they graduate compared to freshman business majors? 55% of the 640 freshman psych majors from a recent study changed their major before they graduated, and 55% of the 680 freshman business majors changed their major before they graduated. What can be concluded at the alpha 0.10 level? So again, so practice exam, a lot of the battle is recognition, percentage. So we go down to the exam 4 notes and we go, is it proportions or means? Is it means or proportions? It's proportions because there's percentages. There's not means. There's no averages anywhere. There's only percentages. Okay, and there's 2 percentages, aren't there? There's 2 of them. So we go, oh, okay, so it's 2 proportions. So what do? We use the 2 prop Z test or the 2 prop Z interval. Which one is this? Is this a hypothesis test or a confidence interval? Well, look at all that. That's a hypothesis test, isn't it? HOH1. That's it. It even says hypothesis right there. So it's hypothesis. So we're going to use 2 prop Z test, aren't we? And so then it tells us what to do. HO is they're equal. H1 is greater, less, or not equal. So HO is the two are equal. Later, greater or less. Okay, so here we go. So this is going to be, we're going to use 2 prop Z test. I don't know the exact words it uses there. I guess I could look it up real quick. Oh, Z test for difference. Yeah, so the option you're going to choose is Z test for the difference between to population proportions. So that's what we're going to choose there. And how do we know that? Well, because we're doing a 2 prop Z test on our calculator. How do we know that? It tells us right here. 2 prop Z test when you have 2 proportions. All right. So we know that, and then come down here, it tells us P1 equals P2. Where do I know that? Right here. The HO is P1 equals P2. And then the H1 is one of these 3 options. How do we know which one? Well, we have to get that from the words. What are they saying? Do you see anywhere, are they saying P1 and P2, are they saying greater, less, not equal? Those are the 3 options, right? I'm just looking right here. It's greater, less, or not equal for H1. So which one is it? What do they say in these words? Let's read it again. Are freshman psych majors just as likely? There we go. Just as likely. Notice it doesn't say greater. It doesn't say less. They're basically saying, are they equal? Just as likely. If one thing is just as likely as the other, that means they have equal probabilities, don't they? If I say, hey, yeah, I'm just as likely to have water in the morning as I am to have juice in the morning. That means, same percent, about half and half. Just as likely means equal, doesn't it? So therefore, I'm testing equal versus not equal. Does that make sense? How I discovered that? From the words. Now, if they had said, are freshman psych majors more likely? Well, that would have been greater. Or less likely, that would have been less, right? But if they say just as likely, they're asking if they're equal or not equal. That's what they're saying. Are they equal or not equal? Just as likely. Let's keep moving. The test statistics. So now we're going to go to our calculator and we're going to do the 2 prop Z test. So when you go to 2 prop Z test on your calculator, so I'm going to go 2 prop Z test. So I'm going to go number 1. I'm going to go to stat, go over to tests, go down to 2 prop Z test, which for me is, which is number 6. hit enter. And when you do, you get a bunch of options, as you know. And it says X1. Let me give a little more room here. X1, N1, X2, N2. Okay, this is a little different. I want to make sure you see this right now. And what do we do for X1? What is X1? X1.
That'd be 0.55 out of 640.
Yeah, right. X1 is the number in the first group. Yeah, you're right. It's 0.55 times the 640. Excellent. That's exactly why. Because 55% of, remember, of means times. That's important to know in math. Of is always times. So it says 55% of the 640. So you've got to actually put into X1 0.55 times 640, and then it'll pop up on the screen there, 352. Does that make sense? A lot of people get fooled about this on the exam. Are you hearing me on this? I want to make sure you get this and are not fooled on the exam. I don't want to fool you, but I do have to test that you really have learned the concepts. Do you see that? This is a little tricky. We have to actually multiply those. Why? Because, and well, then what's N1? N1 is 640. That's, and maybe I should, let's say, I don't know how to do the difference here. And the X1 is, what is X1? It is the percent times N1. That's a better way to do it. And then this is just N1 here, which is the number. So that's actually group 1. So there's 640. Remember, N always means how many in the group. So group 1 size. So this is a better way to say it. Yeah, let me do it this way. Group 1 size is 640. There's 640 in group 1. 352 people out of 640 in group 1 changed their major. Do you understand what it's saying there? They're asking, are freshman psych majors just as likely to change their major before they graduate compared to business major? We're wondering which group changes their major more often. Well, 55% of the 640 freshman psych change. Well, how many people is that? 55% of means times 640 is 352 people. So 352 out of the 640 psych majors changed their major. Just over half. And now how about for the next group? For the next group, it's going to be, again, percentage times N2. And then group 2 size. This is group 1 size here. So group 2 size is, what's group 2? So here's group 2. So it's going to be 0.55 times 680. And just put that right in. Just put that right into your calculator. You don't have to calculate it on the side and then put it in. You can put it right into that entry on X2. It'll calculate it automatically for you, come up with 374 people. 55% of 680 times 680 is 374 people. And then this is just 680. So 374 out of 680 of the business majors changed their major. All right. So now once you get all that in, then what are you going to choose down here? We're going to choose not equal, at least I will for mine, because not equal, whatever H1 has, and hit enter. And then let's see the numbers. I'm getting a Z. Your tested statistic is Z. I'm getting straight out 0. My p-value, I'm getting, it says wants me to round to 4 places. I'm getting 0.9s forever, which really rounds to 1.0. right? You with me? Right, 0.9 is forever. That rounds to 1.0. But if you want 4 zeros, that's fine. 1.0000. It's just 1. Are we good there? All right. And then now for the real, I'll just make this is just 1.0. What the question that we always answer, how does the p-value compare to the alpha level? So again, the p is 1.0. What's the alpha? Right here, 0.10. 0.10. 1.0 is much greater than 0.10. 1.0 really means 100%. All right. And so what does that mean about our conclusion? You know how we do these conclusions. I'll write it right here. If the P is low, the HO must go away. But RP is not low, right? It's greater. RP is greater. The P is not low, then the HO must not go away. We're going to keep the HO. So I'm going to keep the HO, which means keep this, which means keep the idea that they're equal. Of course they're equal. Look at them, 55% and 55%. Of course. Now you might say, why do we even do this study? Of course they're equal. Well, there's always the chance of luck. We're saying that we should stick with the assumption that they are equal. All right, so now is there strong evidence or weak evidence? Well, this is always weak, isn't it? Always weak evidence for the HO. The H1, if we had gone with him, he would be strong evidence, right? The HO, we always assume the HO, like assuming innocent when somebody's accused. You assume HO, and if evidence is weak, you stick with HO. That's what we're doing on this problem, right? We're crossing off H1, and we're sticking with our original assumption of HO because evidence is weak. Meaning what? There's weak evidence that they're different, right? They came out with exactly the same percentages. There's basically no evidence that they're different. That's why the p-value came out with 100% chance of luck. 1.0 decimal is the same as 100%. There's a 100% chance of luck. There's a 100% chance that they're not really different, right? They came out the same. So what are we going to say down here? There is statistically significant? No, not significant. Yeah, insignificant. That's right, insignificant. Get rid of the significant. So which one of those insignificance is right? Because evidence is weak, which is insignificant. So there is statistically significant evidence? No. They went back to the word significant. So there is statistically insufficient evidence to conclude that those who change their major is different. Right, there's not enough evidence to decide that they're different. We stick with the assumption that they are the same. So there we go on that one. Are you good with that conclusion? I noticed a lot of people get confused on the conclusions. Make sure you're really spending time thinking about how these conclusions go, because that really matters, obviously, right? Wouldn't it be silly to do all these numbers and not know what they all mean in the end? So you definitely will be tested on exam number 4 as to your understanding of the meanings of conclusions. So don't just click these boxes again and again and again, and if you get it wrong, just click another one and not spend time thinking about it. That's not how the test will work. You'll have one shot, and you need to know how to do this stuff. So do you understand why this is the conclusion? Right? Insignificant, insufficient. To conclude, where there's not enough evidence, there's insufficient evidence to conclude that they're different. So there's not enough evidence for difference. Right. That's what we concluded. There's not enough evidence for difference. There we go.